Okay, today we're going to continue looking at graphing. I'm going to share my screen with you. And it's going to be a fairly quick lesson where we talk about these special lines that we've seen before, where we have just a horizontal line. We know those have a slope of 0, or just a vertical line, and those have a slope that's undefined. And I have kind of special words that I use for these types of graphs. So for our horizontal line, I call those lines a HOI. Okay, and HOI stands for a horizontal line, 0 slope, so that O is supposed to represent 0, and the Y is because these graphs look like Y equals a number. So I call these HOI graphs. For example, if I'm asked to graph Y equals 2, and so I have to know how to look at that, because in terms of rise over run, there isn't a rise over run, right? So Y equals 2 is Y equals 0x plus 2. So how do I graph that when my slope is 0? So anytime I see Y equals a number, like here, I know that this would be a horizontal line where Y equals 2. And I know that my slope is 0. So, okay, it's a Y equals a number. It has 0 slope and it's a horizontal line. Y is 2 right here, and a slope of 0 would mean that I have a horizontal line going across where Y is 2. And if I looked at ordered pairs here, so this is a y-intercept, so I can say 0, 2, or I have a point at 1, 2, or I have a point at 2, 2, or 3, 2, or negative 3, 2, or negative 10, 2 would be another point on that line. Okay, but notice that all of my Y values for all of these ordered pairs would be 2. Okay, and it's that simple. Y equals 2, Y equals 2. X can equal whatever. Okay, Y will equal 2. And also this is still a function because every input here, all my X values go to only one output. Even though it's the same output, it's still a function. Okay. Now my other line that we look at are our vertical lines, and I call those VUX lines. V-U-X. Okay, so V for vertical, U for an undefined slope, and X because these equations look like X equals a number. So X equals a number, for example, if I had X equals negative 2, if I think about how this is, okay, because now this is not a function. I don't have slope. There's no Y equals here. If I think about what happened up above, well, first of all, let's talk about what this even means. It's X equals a number. Its slope is going to be undefined. It is going to be a vertical line where X equals negative 2. Where X equals negative 2. And if I use what we looked at here, that means if I were to list a whole bunch of ordered pairs here, I could say, well, I have negative 2, 0. I have negative 2, 1. I have negative 2, 2. I have negative 2, 3. I have negative 2, maybe negative 3. Okay, that Y can be changing, but X is always going to be negative 2. And it's going to be a vertical line where X is at negative 2. So I have negative 2, 0, negative 2, 1, negative 2, 2, negative 2, 3, negative 2, negative 3. That's what my graph looks like when I'm given something that looks like X equals negative 2. And all of my inputs, all of my X values in those ordered pairs are always negative 2. And that input goes to all sorts of infinitely many outputs. That makes this not a function. Okay, so let's flip this over and look at a couple of examples, and I'll let you try a few on your own. So when I'm presented with an equation, which you can see down below, sometimes we rewrite it and we end up with something that looks like that. But let's say I'm given 3y equals negative 9. So first I'll isolate y. Y equals -3. And then I look at that and I go, okay, it's y equals a number. That's a HOI, meaning it's a horizontal line with 0 slope where y equals that value. That's how I kind of think about what that graph looks like. So where y equals -3, I will have a horizontal line with 0 slope where y equals -3. On my other graph, my x equals graph, so let's say I had something like x subtract 5 equals 2x. Yeah, let's just leave it like that. So here's an equation. There's no y. I want to isolate the variable I have. So I'm going to subtract x, which would give me -5 equals x, or x equals -5. And I go, okay, this is one of those special equations. This is just x equals a number. There's no y involved here. I know that that special equation is a VUX, meaning it's a vertical line with undefined slope where x equals that number. X equals -5, vertical line where x equals -5, and there's my graph. So the graphing should take you all of like a second. Okay, it's identifying that something that looks like this, y equals a number, or something that looks like this, x equals a number, has this special kind of graph that I need to think about. This is a horizontal line, 0 slope, when y equals a number, vertical line, undefined slope, when it's x equals a number. So underneath here, there's 6 examples, and I want you to pause the video, try, the first 3 are set up for you. The bottom 3 you have to rewrite so it either becomes x equals or y equals, and see if you can graph each of these equations. So let's talk about what these graphs should look like. So first of all, on my first one, I go, oh, it's x equals a number. That's a VUX vertical line where x is, in this case, -3. Graph a vertical line where x is -3, and I'm done. On the second one, it's y equals a number. That would be a HOI, a horizontal line where y is 5. I put a point at where y is 5, and I draw a horizontal line, and I'm done. See how fast these are once you kind of get used to what you're looking for? This one looks a little bit funny. So I have a vertical line where x is 0. X is 0 at the origin here. And so a vertical line is literally going to be running along the y-axis, okay? When I get to the second row, I'm not quite ready to graph right away. Like this isn't a horizontal line where y is 16. I need to divide by 4 on both sides, and it's going to give me a horizontal line where y is 4. So y is 4 here, horizontal line. Same idea on the second example in this row, I need to add 7, which would tell me I have the line x equals 5. X equals, that's a VUX. It's going to be a vertical line where x is 5. The last one, we have quite a bit of rewriting to do. So first, let me move 2y over. I get 2y minus 6 equals -4, and I add 6, and 2y equals 2, and I divide by 2, and y equals 1. And I go, okay, it's y equals a number. That's a HOI, horizontal line, where y is 1. There's my graph. Okay, and so we should be looking for these in our graphing practice in the next couple of days, and getting really quick. Like these take, like I said, all of like 2 seconds to get the graph down once we understand the concept. It's having that concept solid enough that we don't get thrown off when we encounter a problem that looks like either y equals or x equals.